There's a version of you that no longer exists in your own memory. A version that learned to recognize your mother's voice, felt hunger for the first time, cried, laughed, was held. And you remember almost none of it. Not because it wasn't important, not because it didn't shape you, but because your brain, quite literally, wasn't built yet to keep it. This isn't just a personal mystery. It's a real, well-documented phenomenon, and psychologists actually have a name for it: infantile amnesia. Most people's earliest memories don't begin until somewhere between ages 3 and 4, sometimes later. Everything before that, the first steps, the first words, the first birthday, exists only in photographs and stories other people tell you, not in your own mind. So what's actually happening in there? For decades, researchers assumed babies simply weren't forming memories at all, but that turns out to be wrong. Psychologist Carolyn Rovee-Collier, whose research focused on infant memory at Rutgers University, demonstrated that even babies as young as 2 or 3 months old are capable of forming and retaining memories. In her famous mobile experiments, infants learned that kicking their leg, which was tied by ribbon to a mobile above their crib, would make it move. Weeks later, when placed under the same mobile, they remembered exactly what to do, so babies can remember. The question isn't whether infants form memories, it's why those memories don't survive into adulthood. Part of the answer lies in a structure deep inside your brain called the hippocampus, the region primarily responsible for consolidating short-term experiences into long-term, retrievable memories. Neuroscientist Paul Franklin at the University of Toronto has studied this extensively. His research shows that the hippocampus continues developing well into early childhood, and during infancy specifically, it's producing new neurons at an extraordinarily rapid rate, a process called neurogenesis. Here's the twist. That rapid neuron growth, the very thing that makes infant brains so remarkably adaptable, may actually be what erases early memories rather than preserving them. Franklin's studies on mice found that high rates of neurogenesis appear to disrupt existing neural circuits, essentially overwriting the connections that would otherwise hold onto a memory. In other words, your infant brain may have been changing and growing so quickly that it was constantly clearing its own hard drive just to keep building itself. But there's more to it than pure biology. Language plays a surprisingly enormous role too. Psychologist Catherine Nelson, who spent decades studying early childhood memory and language development, found that children's ability to form lasting, narrative memories is closely tied to their growing language skills. Before a child can really talk, before they can form structured sentences describing what happened to them, they don't yet have the mental scaffolding to organize an experience into something that reads internally as a story with a beginning and an end. Think about how you remember things now as an adult. A memory usually isn't just a raw sensory snapshot, it's a story. This happened, then this happened, and it made me feel this way. That structure requires language, requires a sense of self existing continuously through time, connecting yesterday's you to today's you. A baby simply doesn't have that internal narrator yet. This connects to something else researchers have identified, a developing sense of self. Psychologists studying childhood cognition have found that a stable, continuous sense of me who exists across time doesn't fully form until roughly the same age children start retaining lasting memories, somewhere around age 3 or 4. Before that point, there may not yet be a consistent enough self for experiences to attach themselves to. It's a strange thought. Before that age, you existed, you felt things, you experienced your life fully and completely in each individual moment. But there wasn't yet a stable narrator sitting behind your eyes, threading those moments together into a continuous story called my life. That narrator was still under construction. There's also a physical growth story happening simultaneously. A child's brain roughly doubles in size during the first year of life alone, and continues rapid growth through early childhood, according to developmental research published by the National Institutes of Health. Entire neural networks are being built, pruned, rebuilt, and reorganized during this period, at a pace that never happens again at any other point in life. It's not that your brain failed to save your earliest memories. It's that it may have been almost too busy building itself to keep them. So what happened to those early experiences? Are they just gone permanently with no trace at all? Not necessarily. Some researchers believe early experiences, even ones you can't consciously recall, may still leave lasting imprints, not as retrievable memories, but as something closer to emotional or behavioral tendencies. Attachment researchers, building on the foundational work of psychologist John Bowlby, have found that the quality of care an infant receives, even in the earliest, unmemorable months of life, can meaningfully shape their sense of security and relationship patterns well into adulthood. You may not remember being held, but how you were held may still be quietly shaping you. There's also an interesting wrinkle in how infantile amnesia has been studied more recently. A 2023 study led by neuroscientist Nick Turk-Brown at Yale used functional MRI to scan the brains of infants as young as 4 months old while they viewed images. Remarkably, the study found measurable hippocampal activity patterns associated with encoding memories, activity that resembled adult memory formation far earlier than researchers previously assumed. The forgetting, it seems, may not be a failure to record. It may be something closer to an active process of loss, or perhaps simply a failure of adult retrieval systems to access memories stored in a fundamentally different, pre-verbal format. That's a genuinely strange idea. Somewhere in you, there may be a version of those memories still technically stored, encoded in a format your current, language-based, narrative-driven adult brain simply no longer knows how to read, not deleted, just untranslatable. So the next time you look at a photo of yourself as an infant, someone you technically were, wrapped in a blanket, held by people who loved you before you could even understand what love was, remember this. That absence of memory isn't a flaw. It's evidence of exactly how much work your brain was doing in those earliest months, building itself, layer by layer, into the person capable of remembering anything at all. You didn't lose those years. You simply weren't finished yet. The version of you capable of holding on to them hadn't been built.